Welcome back, geographers, to another episode where we will be doing map work, geographical skills and techniques, yes, and we are going to focus on today map skills and applications. For today's lesson, we've got to ensure that we are well equipped with the necessary topographical maps, orthophoto maps, as well as question papers of Geography Paper 2 from 2014 November to 2019 November. So let's have a closer look at what is our focus today. So for today's lesson, we'll be focusing on, yes, the 2014 November Geography Paper 2, which examined the topographical map of Cullinan, the 2015 November Paper 2, and the Queenstown map, the 2016 Geography Exam Paper 2, which examined the Falkirk map, the 2017 November Paper 2, Paris, the 2018 Pietermaritzburg, and the 2019, which examined Pongola. For you to get the best possible appreciation of today's lesson, ensure that you ask your teachers for these maps, as well as having those Geography Paper 2 examination papers, because we'll be zooming into how for you to get acquainted with the application of those critical theory skills that you need to apply onto topographical maps as well as orthophoto maps. So let's look at what we've got to do. For this lesson, I've been able to analyze these examination papers and draw out essential components from theory that are being examined on maps. This would be to familiarize you with the essential elements that you need to draw from your theory in geography and study well to be able to apply onto these maps. Let's look at it in detail. So, for climate and weather, the following aspects have been examined: the precipitation with a major emphasis on rainfall, microclimates, and note only valley and urban climates have been examined, so you should be focusing on those. In geomorphology, over 2014 to 2019, the following aspects: types of rivers, the direction of stream flow, stream channel characteristics, stream channel formations, and drainage density. When looking at questions 3, in terms of rural and urban settlements, the following were examined on topographical maps: site situation and distribution, settlement patterns, settlement types, comparing different types of settlements, as well as land use and land use zones. In economic geography, the application considered types of economic activities, mining, as well as agriculture, types of industries, transport, and these were the essential elements that these examinations focused on. So let's make a start with the application of climate and weather on maps and what has been examined from 2014 right up to 2019 and where the emphasis was. And to do this, we looked at, in terms of climate, the following. You'll note that in terms of your examinations in 2014, precipitation with special emphasis to the type of rainfall on the map of Cullinan was examined. In 2015, the map of Queenstown, precipitation again, type of rainfall, as well as valley climates. 2016, on the map of Falkirk, the emphasis was on valley climates. In 2017, the map of Paris, again, precipitation, as well as, for the first time, urban climates. In 2018's Geography Paper 2, which dealt with the map of Pietermaritzburg, you had valley climates. And in 2019, as early as last year, on the map of Pongola, the emphasis was on valley climates. So clearly, when it comes to the understanding of climate and weather and the emphasis of where this is examined on a map, the crucial aspects of any map is to be able to examine the type of rainfall experienced in that area, as well as applications of microclimates with particular emphasis to valley climates as well as urban climates on a map. What we will do now is look at and group these according to these themes. That is precipitation as well as valley and urban climates. We start off with our first map, which is the 2014 map, and note it is the map of Cullinan, and the emphasis on this particular one was precipitation. Let's look at the question. The question reads, does Cullinan receive seasonal rainfall or rainfall throughout the year? Now, note the following. There are only two types of rainfall in South Africa. Either seasonal rainfall, which means rainfall that occurs in a specific season, example, summer, or rainfall throughout the year. Now, immediately you would be able to determine that South Africa is a low rainfall area as it falls on the, yes, high pressure belt. And it's influenced by the three anticyclones, your South Indian, South Atlantic, and Kalahari High, which means that the majority of the rainfall over South Africa falls in summer. It is only the Western Cape that has rainfall with specific location of the Cape Town during rainfall in winter. So what does this mean? South Africa is a reasonably dry country, and we experience seasonal rainfall throughout the year. Looking at the question, Cullinan, which is located in central Gauteng, to the northern part of Gauteng, has seasonal rainfall. But what's more important is for you to identify the evidence on the map. And the evidence on the map is as follows. Seasonal rainfall. And what tells us this? What tells us this? The fact that there are storage dams on maps. So whenever you are asked a question on the type of rainfall, remember there's two types, either seasonal rainfall or rainfall throughout the year. And the evidence for seasonal rainfall on any topographic map that you will be exposed to is the presence of, correct, storage dams, non-perennial rivers, and so on. Let's look at the next question to become more familiar with it. Give evidence from the topographical map. Let's go straight to the answers. Note the answers: non-perennial rivers, periodic rivers, dams, reservoirs, and windmills. These are just some of the evidence that you will be focused on when analyzing the map. And if you see these symbols on any topographical map, whether it be in examination or in a test, you should note seasonal rainfall is associated with these symbols. Let's look at the next question. So the next question is on the 2015 November paper, and note the following. Queenstown generally experiences low annual rainfall. State two steps that people in the area have taken to manage this shortage of water. Note the difference in the language that is used. We're still trying to analyze precipitation. Although the question has changed, the idea, the concept is still the same. Is it seasonal rainfall? Yes. However, note in this examination, it is expressed as low annual rainfall. And what is it that the question requires you to answer? Again, look for the evidence. We've had evidence of reservoirs, non-perennial rivers or streams, periodic streams, as well as water points. Now, all these are sources of water that are found on a topographical map. Here's your answers. Storage dams, wind pumps, water purification plants, canals, furrows, reservoirs, weirs, or water points. These are the examples of what you should be finding on maps in terms of your symbols as evidence for, correct, seasonal rainfall. It is very rare that you'll have a map or a topographical map from South Africa where there's rainfall throughout the year, except in the location of Cape Town, which is in the Western Cape. Remember, if it's found on other parts of the country, the rainfall is seasonal. Even in the coastal belt of KwaZulu-Natal, which is supposedly receiving lots of rainfall, There are a number of storage dams. There are non-perennial streams that flow across from the Drakensberg straight down the lower marginal belts to the east coast. This means that there are seasons that are dry and we're not receiving as much rainfall. So, what is the key concept here? If this is the way we're going to look at it, again in 2017, notice the question and how it changes. The mapped area receives seasonal rainfall. Note in this examination, you are being told it is seasonal rainfall. What is your requirement? Give 2 points of evidence from the topographic map to substantiate the statement. How simple is this now? All you have to do is find that evidence by referring to symbols that denote seasonal rainfall without even looking at the answers. Reservoirs, correct. Non-periodic streams, non-perennial streams, periodic or non-periodic rivers. So let's look at those answers. Non-perennial rivers, dams, wind pumps, furrows, reservoirs, or irrigation. And these forms of irrigation, remember, include furrows. So this is but for you to remember that whatever examination you are studying, you are looking at the theme across this examination. And if precipitation is examined in terms of the type of rainfall, you should note that the experience from previous examinations suggests that all we have to know is that South Africa, the majority of South Africa, experiences seasonal rainfall. And all you have to do, refer to your map reference, and you will be able to find all the symbols that denote seasonal rainfall. Reservoirs, storage dams, non-perennial streams, and so on. Can you see how easy it is when you analyze different examinations and identify the theme that is being examined? Let's look at the next one. The next one talks to valley climates. So in 2015 November, the first of the geography paper 2s that examined valley climates. And note what we've done to this map. In this particular map, I've been able to use raster data to show you the image of high-lying areas. Now, in any map, you have to be able to identify where the valley is. Where does the slope go downwards? And if you look at this particular map, note the high-lying area where your contour lines are close together. Note the high-lying area where the contour lines are close together, which means that your valley winds move downslope. And yes, these are katabatic winds. So in essence, what the examinations on valley climates examines is your ability, the skill for you to identify where the highest slope is and where the low slope is, and how does those winds move. Taking into account that katabatic winds occur at night where the air moves down the slope, and anabatic winds where the air moves up the slope. So let's look at the types of questions that you will experience. In this particular examination, with reference to Queenstown, its location in a valley, give reasons why it regularly experiences frost, a condition associated with, yes, katabatic winds during the night in winter. If we're analyzing this particular question, we can immediately see that the question already has predetermined our knowledge. We should know that at night you're experiencing katabatic winds or gravitational winds that flow down into the valley. In this particular example, note the air is moving downslope from the highest point. These highest points are determined by raster data on the color of the map. Let's look at the answers for this one. The cold, dense air. Katabatic flow causes air to move downslope due to gravity. Very good. As well as air collects on the valley floor. So what this simply means is that as the air moves down the slope, it collects on the valley. And at night, because of the lower temperatures, what is happening? Your temperatures are below 0 degrees and frost formation is inevitable. This is some of the precipitation associated with valley climates. What is the question suggesting? The question is suggesting that you already have the pre-knowledge of katabatic winds. When you see at night, you already know the air is moving down slope in a valley, and therefore collecting on the valley floor, becoming colder because of its lower temperatures, and the formation of frost is inevitable. Can you identify this? How many tasks have you been able to work through? Let's move on to the next question. The next question was in 2016, and again note the examination of valley climates. And in this particular example, we had the following. Refer to the valley between spot heights 1709 in block H9 and the trig station 241 in block G10 on the topographical map. Why did the farmer select V to grow his crops? Notice, matrix, how the examination language changes, but the concept remains the same. We are still examining valley climates. We are still testing your knowledge on both anabatic as well as katabatic winds. And therefore, if you had the pre-knowledge going into an examination of anabatic and katabatic winds, you should be able to know how to apply this on a map. And in this particular map, note that the following is applicable. The site V, there's V. Note the contours in this particular area showing you a steep slope, meaning that the air is moving down slope. Note the contours here, moving down slope as well. So this particular area, which shows you high levels of cultivation, is experiencing katabatic winds at night. And if it's katabatic winds at night, the forms of precipitation that are associated is frost, and frost-resistant crops must be grown. This is according to our theory. Now that we're looking at it on a map, the following is applicable. Note the gentle flat land, the floodplain that is associated with area V. The floodplain includes the water sources. And if you look at the next question, the farmer at V noticed that the early morning mist in winter starts to clear from the bottom of the valley. Explain. Again, associated with your valley climates, like frost, is mist. And mist is most applicable in the mornings after the katabatic flow. Once the sun's up, the temperatures start increasing, and therefore the mist has to clear from the bottom of the valley. Another form of precipitation associated with valley climates. What is the steps and processes involved? Let's look at some of the answers that are possible. The sun heats up the slopes in a valley. The next one, terrestrial radiation takes place as well as moist air evaporates from the bottom of the valley floor. So what this simply means, and remember, terrestrial radiation is where the insolation or the incoming solar radiation heats up the Earth's surface, and anything in contact with the Earth's surface, which is your atmosphere or air molecules, is heated because of the radiation from the Earth's surface, giving rise to the air molecules, and therefore removing all that mist in the valley floor. So there's your slope, and you've got all this air masses existing at the bottom. And what's happening? Terrestrial radiation. The surface is being heated, and the air moves away from the surface in a convection current. Let's look at the next one. The next one, again, valley climates in 2018 November. And in this particular one, you have the following. The bottom of the valley at area M on the topographical map experiences frost during the early hours of the morning. So yet we're noting again, how is the examinations taking place? We're looking at valley climates, but we're focusing on the types of precipitation and their impact on human activities and how these affect growing of crops, agricultural practices, and so on. Look at the question. Name the local tertiary wind that is responsible for the formation of frost. Which one is it? Anabatic or katabatic? You there? Correct. It's katabatic. Well done. Katabatic winds because katabatic flow is at night. And what's the next question? Explain how the wind mentioned in question 3.1 causes frost. The following factors are applicable. Cooler slopes increase the density of air masses. So what is this saying to us? It is saying to us that at night, the slopes are cooler because of the lower temperatures. This forces air molecules to descend because of the force of gravity. And what happens? Its density increases. Therefore, it's forced to move down. The cooled air descends to the bottom of the valley. And what happens here? The cold air accumulates on the valley floor and is trapped below the inversion. Now remember, your inversion layer is a layer that exists above the valley floor but traps all that air that is sinking towards the bottom of the valley. That inversion layer keeps the air below temperature so that precipitation, example frost and mist or radiation fog, can be formed. So what you should be noting when it comes to the examination of valley climates on maps, number one, be able to identify where your steep slopes are and determine the direction of that slope and the direction in which the air is moving. Once you've established those directions, you should be able to determine where the form of precipitation occurs on the valley floor. These are often given to you, so the skill involved is identifying and being able to elaborate on where and how the precipitation is being formed. Let's go to the next one. The last one in 2019, remember the map of Pongola, is as follows. You have the following question. Refer to the settlement of Pakamisa situated in the valley in block J4. Note in this exam, you are being given the valley floor, you are being given the location, and obviously the level of application has to improve. So, what is the question? Explain why the impact of katabatic winds will be minimal on the settlement of Pakamisa. Now, focusing on Pakamisa in this particular map, you should be able to find its location. And the location is given in the question as J4. So when we're looking at J4, here's our settlement, Pakamisa. And in Pakamisa, the following is applicable. Why the impact is less. Notice Pakamisa in this particular example is located in the middle of the slope. There's the top of the slope, and note how the air is moving down the valley. Do you see that? Now, immediately you should be able to determine that Pakamisa is located on the middle of the slope. That means there's still steep slope below that settlement. Will it be affected by katabatic winds? Yes, but not by frost or fog or exactly mist. Why? Because all these forms of precipitation occur on the valley floor. Pakamisa is located on the mid-slope. So, why is it impacting? The cold air drains the valley floor below Pakamisa. In this particular example, frost forms on the valley floor. So immediately you should be able to determine that all the air that passes along the slope flows into that way or that way, dependent on how this slope is. So can you see the skill involved? The skill is you must be able to identify where the contour lines are, where the steep slopes are, where the gentle slopes are, and why katabatic winds or anabatic winds are impacting on those human activities. So, moving on to the next. In this particular example, we were using the topographical map. And what I want you to note is when it comes to the examination of both climate and weather on topographical maps and orthophoto maps, you must be prepared to analyze the weather conditions in both. We have established that forms of precipitation, particularly rainfall, as well as valley climates or urban climates can be examined. However, the ability of you to know the shape and arrangement of contour lines will assist you in analyzing climate and weather on a map. So Let's look at these questions. Again, in 2018, notice aspect was examined, which is a form of a microclimate. In this particular example, refer to slope 5, which is a low-income residential area, and slope 6, which is a high-income residential area on the orthophoto map. The question is as follows. Explain how the aspect of slope influenced the site of high-income residential area. Here's a form of integration which happened in 2018. The aspect of a slope means simply, is it a north-facing slope in the southern hemisphere? What have we established from grade 10 and 11? If it's a north-facing slope in the southern hemisphere, like South Africa, it receives more sunlight. People prefer living on slopes where there's more sunlight. So what does this mean? We are examining on our orthophoto map our understanding and knowledge of the slope. Again, your ability to identify the slope, which is north-facing and receiving more sunlight. In this particular example, slope 6 is a north-facing slope. Notice the following. Here, on this particular orthophoto map, we have what we call Town Hill, which is the name of the settlement. The settlement has various different locations around it. However, this is your north-facing slope, which means that you have sunlight which comes through directly on this slope, increasing its temperature. So, what have we established? The north-facing slopes in the southern hemisphere receive more sunlight and therefore are warmer. If they are warmer, you have more settlements forming on north-facing slopes. Stands to reason, people prefer living in warmer climates. And in terms of the direct sunlight, natural heating is possible. So, what is being examined? Again, your ability to identify the slope by looking and analyzing at the contours, you should be able to determine which is a north-facing slope and which is a south-facing slope. And according to the theory of aspect, you should know that the north-facing slope receives the direct sunlight, therefore higher in temperature. In this particular example, this is your south-facing slope and therefore receives less sunlight. Notice your north-facing slope has more sunlight. Your ability to recognize the north-facing slope is going to determine how well you answer this question. Let's look at the next one. Again in 2018, slopes 5 and 6, the next question read as follows. Give one reason evident on the orthophoto map which influenced the location of low-income residential area 5. Again, we are comparing two types of slopes, slope 5 and slope 6, and trying to determine how these slopes are differentiated in terms of residential. And if you look at slope 5, notice in slope 5, here's your slope with a settlement that is located there. This slope is, when compared to slope 6, much smaller and therefore receiving less sunlight. And if there's less sunlight, its inhabitants will be that much less, its property values will be that much less. Let's look at the possible answers for this one. South-facing slopes have a lower value on properties. It stands to reason that where there's warmer climates, the property value will be higher. You'll notice that most of your larger homes, especially on north-facing slopes, are built with materials like glass. Why? They allow natural heating to enter through glass, being transparent, and naturally heat the homes. So, climate, weather, notice how your ability to identify the slope, the type of slope, is enabling you to get marks. All you have to do is analyze the arrangement of contours, determine in which direction the slope is facing. Is it a steep slope or a gentle slope? And once you've done that, you'll be able to analyze and determine how anabatic or katabatic winds affect the valley floor as well as the direction of the slope. The next one that we look at is again valley climates, and working through this, notice the way the question is phrased. Again on Phakamisa, in which direction does the settlement of Phakamisa face? And again, It's a north-facing slope. For this one, explain the climatological advantage of the location of the settlement of Pakamisa, and in this example, the direct insolation on the slope. Again, a similar type of question with the same application, but the phrasing is different. Your ability to see and work through the different language and phrases to see that the same aspects are being examined. So, once you've been able to master your theory, it's about applying the same theory to different maps. Located in the middle of a slope, again, that's referring to Pakamisa. And now we're moving on to geomorphology. And note, again, when we're looking at geomorphology, we are trying to understand how fluvial processes impact on the various maps that we have studied. After analyzing from 2014 to 2019, the following is evident. In 2014, the direction of stream flow was examined. Again, in 2015, the direction in stream flow as well as fluvial formations. Notice in 2016, again, directions in stream flow. 2017, stream patterns and drainage density. 2018, fluvial formation. And in 2019, on the map of Pongola, types of rivers and fluvial formations. Immediately, when it comes to application, we can determine a pattern of how the examinations are examining, correct, on different maps, the same theory. How do we examine this? Let's take a closer look at the types of questions. And in this particular example, we start off immediately with the map of Cullinan in 2014. There's the block C8, state the general flow of direction of the Masokolo River in block C8. And notice the extract. You have the Masokolo River flowing, and you are asked to determine the direction of flow of the river. What are the crucial elements and symbols you need? You will need to, again, analyze the contours, determine the heights of the contours so that you can be able to determine where's the higher height and where's the lower height. And in this particular example, let's look at the answer. The direction of the river is north. Now let's motivate that. Notice the dam wall in this particular example. It is, the streams are flowing towards the dam wall, and therefore the water flows out. Again, notice the height. Again, 1364 is your spot height. Therefore, this particular river flows in a north direction. Also, it's suggested that the dam walls face in the direction of the lower height. Notice the reservoir. And in this particular example, give one reason from the topographical map. Your answers are as follows. The position of the dam wall. Again, let me reiterate that answer. The position of the dam wall faces in the direction of the lower height. The V-shaped contours. In this particular example, note that there's your contour, and notice the V shape. The V shape always points upstream. And this is crucial. When you're looking at the contours and it has a V shape, the V shape is always going to point upstream, which means that the river or stream flows in the opposite direction. And the last one, the tributaries joins the main river at an acute angle. Notice in this particular example, there's your main river and there's the tributary. Look at that angle there. That's an acute angle. And if it's an acute angle, you know that that is the direction of the river flow. Let's look at the next question. And in 2015, note the following. There's your map of Queenstown, and in this particular example, the Claas Smits River between blocks G1 and J6 give the general direction in which the Claas Smits River flows, and notice how the similar concept is being examined on different maps. And you've got to be able, whatever map or topographical map you've been given, to analyze in terms of direction of flow. And how do you do this? Notice the contours. The arrangement and heights on the contours would suggest the direction of flow of the river. In this particular example, we've established a southeasterly direction. Note in this particular example, we've got an extract of a map, and you are required to determine a general direction. And looking at this map immediately, upon seeing various different heights on this map, you should be able to determine where the highest height is and where the lowest height is. In this particular example, as the river flows, we notice that here is at point O, 1016.9 as a spot height. And as you move downstream, notice more as the river is flowing, 1025. So as we analyzing, follow the route of the river. Notice whether those contours are increasing or decreasing. In this particular example, as the river moves in a generally southeasterly direction, the values decrease. In the same paper, let's look at the next one. Refer to the perennial stream in block B10 and state the direction of flow in which this perennial stream flows. Give 2 reasons for your answer. Immediately in block B10, here's an extract, and what we'll be looking at is southerly. Note the following. In this particular example, there's your river flowing. Note the direction in which the dam wall is found, and therefore it flows out of the dam, making it a southerly direction river. The next question is the reason for your answer. Note again as a reason, the dam wall is located to the south, contour lines, spot heights decrease to the south, as well as the V-shaped contours point upstream. And these are but a few of the aspects of geomorphology in terms of direction of flow. Let's look at the next time. The next one is drainage density. In this particular example, we are required to look at blocks E4 and F3. Name the drainage pattern in this area. Upon analyzing these blocks, note the following. There's our drainage pattern. It was just trellis, and we have identified it in these following blocks. Note the trellis pattern. And there's your high-lying area. In this case, your high-lying area is the watershed. And this watershed separates the 2 streams, making it a trellis pattern. In this particular example, we are able to see that there's the one stream and there's the other stream. And these streams flow parallel to each other, meaning a trellis pattern. And remember, your trellis pattern has one main stream with short tributaries joining at 90 degrees. So this particular question refers to the topographical map and explain why the drainage pattern developed. And obviously, looking at the answers, the tributaries flow between the steep slopes on the valley floor and join at 90 degrees. So, if it's a trellis pattern, note you have to find a watershed separating 2 parallel streams. Generally, most topographical maps have dendritic patterns, and your dendritic patterns are correct, shaped in the branches of a tree. So your ability to distinguish between drainage patterns from your theory and being able to find it on topographical maps is what's crucial. This is where the skill of geography comes in applying your knowledge to a topographical map. Let's look at the next one. Again, in 2017, drainage density as well as drainage patterns. Is the drainage density of the area high or low? Give a reason for your answer. In this particular example, you will note that the drainage density is very low. Why? There's many non-perennial streams in this particular map. So the reason the drainage density is dominated by non-perennial streams, low rainfall, as well as permeable rocks. Remember, the moment you see permeable rocks, it means water is allowed to infiltrate or penetrates the surface. Why? When the rocks are soft, more water infiltrates. When the rocks are hard, there's greater overland or surface runoff. So, let's look at the next one. In 2015, we examined the following: fluvial formations. And in this particular example, which one of the cross profiles, 1, 2, or 3, will be a representation of line OP. Let's look closely at line OP. And in this particular example, you'll note that there's a meandering stream that is found in block H, as well as this river flowing through block H1 as well as H2. Note the line drawn across the river. In this particular example, once a river is meandering, you have to be able to establish, according to your theory, that a meandering river along its slope has two types of slopes, a slip-off slope as well as an undercut slope. What is happening, guys? Exactly. We are being asked to determine which side is our slip-off slope and which side is our undercut slope. So, let's look at what possibilities there are. In this particular example, there's our equal slopes. So in this particular number 3, you don't have an undercut or a slip-off. In this particular example, you have an undercut slope at point O and a slip-off slope at point P. Look, here's your river bend. It means that the undercut slope should be at point P and the slip-off slope at point O. In this particular example, the slip-off slope is at point P. So both these are incorrect. In this particular example, we should note the following. There's your undercut at point P and your slip-off at point O. And you must be able to use the theory that you've established from meandering rivers and apply it to a map. So understanding where the slip-off is and where the undercut slope is very important. Moving on to the next one, in 2019, on the map of Pongola fluvial formations, let's look at what was being examined. In this particular one, it refers to the map of Pongola on the topographical map. What type of river is the Pongola River? In your theory, you've examined types of rivers, and you should note the following. You can only have 3 types of rivers. A permanent river, correct? A river that flows throughout the year. A non-permanent or periodic river. A river that flows only when, correct, there is rainfall. During episodes of rainfall, you also get an episodic river. The third type of river is called a, correct, exotic river, where the upper reaches, where on the mountain, are found in a wet region and the lower reaches in a dry region. So, in this particular example, you must be able to identify where your permanent river is flowing. Let's look at it. What type of river is the Pongola River? And if you look at the Pongola River as it flows, you'll note the following. Immediately, it is a continuous blue line. And any continuous blue line means permanent, perennial rivers. So as follows. What type of river? Permanent river. Remember, this is the perennial stream is a symbol. The permanent river is the name or type of river. So this question requires you to name the type of river. It can only be a permanent river. If you're referring to the map, it is a perennial river. So the question requires you to name it as a permanent river. Let's look at the next question. Same on the Pongola River, we were asked to analyze this on the map in terms of point S and point R. And in terms of erosion, you should be able to determine that at point S, there is less contour lines. Notice the contour lines? So that means that erosion would be much faster at point S. Notice at point R, more contours. The increased number of contours means erosion happens at a much slower rate. The question reads as follows. Types of rivers and fluvial formations. The question, refer to the Pongola River on the topographical map. Will an oxbow lake be more likely from first at the meander loop R or meander loop S? Give a reason for your answer. And obviously at meander loop S, there is more resistant rock than meander loop R. Look at the resistant rock at meander loop R. This simply means that there is more erosion taking place over a longer period of time. And this erosion means that the meander loop will take much longer to straighten and form an oxbow lake. If we look at the next question, still with the same map, we now move on to the application of settlement geography on a map. And in order for us to understand settlement geography, we are now going to apply. I've got the following for you. In 2014, settlement patterns, land use. And with that, guys, we'll continue for our next episode where we will continue with the application of settlement geography as well as economic geography on a topographical map. Thank you for today's lesson. For the next time we meet, make sure you have your maps and topographic maps ready for us to enjoy another session. Good luck. See you soon.